We are now in section 1.2, measuring and constructing segments. Over the course of this chapter, we are going to be using a compass. So if you have one of those, please bring that to class with you. Now, since we're talking about measuring, we're going to first talk about something you've used since elementary school, a ruler. A ruler can be used to measure the distance between 2 points. A point corresponds to one and only one number on the ruler. That number is called the coordinate, so that is your vocab word. A coordinate is a number used to identify the location of a point. The next vocab word is distance. The distance between any 2 points is the absolute value of the difference of the coordinates. So what does that mean? It means that if the coordinates of points A and B, so let's draw a line here. And on that line we have 2 points. We have point A and we have point B. Now, if we're talking about the coordinates of point A and B, let's let them be lowercase a and lowercase b. Then the distance between point A and point B would be the absolute value of the differences between them. So what that means is this. You could actually take A minus B, and then you take the absolute value of it. You could also take B minus A and take the absolute value of that. So if A, for example, was 5 and B was 7, you could take 5 minus 7, get negative 2, take the absolute value of that, so the distance between them would be 2. The same is true if you did 7 minus 5 the other way. The absolute value of 2 is also 2. So what you would call it then would say the length of segment AB, or AB would be 2. Now this is important. This is how you name the length of a segment. When you name a segment, for example in this case, we just say AB. What that means is the length of segment AB. That's the distance. It's the distance between something. So for example, I'm going to write 2 separate things here. Right here, this means segment AB. This means the distance of segment AB. This is distance. This is just a segment. When you are naming distances, you do not use that. So when you, for example, if I gave you, for example, let's say this is 4 and this is 7. And this is point A, point B. Make this really easy. What's the distance or the length of segment AB? You would say that the distance is AB is equal to 3. Notice that I did not use a segment symbol. This is why it's so important in geometry to label and to put the correct terms down, because if you don't, they mean 2 completely different things. So make sure when you're identifying the length of the distance of something, you are not using a segment symbol. In example 1, I have drawn a number line for you. The points E, F, C, and D are labeled with a red point. The directions say to find each length. So if you look at A, it says DC. You have to understand that means the length. What is the distance from D to C? So we look from D to C. Now, pretty obvious here that when you're talking about D to C, you're talking about 4.5 and 2. What's the distance from 4.5 to 2? Obviously, you subtract them and take the absolute value. The distance would be 2.5. Now we look at the distance from E to F. So E to F, we go from -4 to -1. What is the distance from -4 to -1? It is equal to 3, because we can either take -4 minus a -1, which is -3, take the absolute value of that and get 3, or you can take -1 minus a -4, which gives you positive 3, and the absolute value is 3. Remember, distance is always going to be positive. It's pretty easy once you get the hang of it. Our next vocab word is congruent segments. Congruent segments are segments that have the same length. Now I'm going to draw a diagram here. In this diagram, I have two segments, PQ and segment RS. So I'm going to say that PQ is equal to RS. Now, notice how I wrote this. PQ is equal to RS. That means that the distance from P to Q is equal to the distance from R to S. So then we can also write that as segment PQ is congruent to segment RS. So this is read as segment PQ is congruent to segment RS. Tick marks are used in a figure to show congruent segments. So if we're looking at this again, I want to make sure you understand what we're doing. If you are saying that their distances are equal, you do not use the segment symbol. You are telling me that the distances are equal. Distances use an equal sign. So once you know that the distances are equal, then you can say that the segments are congruent. So segment PQ is congruent to segment RS. And this is read as just how I explained, segment PQ is congruent to segment RS. These red tick marks that I have here are used in a figure to show that the segments are congruent. The next vocab word is going to be a construction. A construction is a way of creating a figure that is more precise. Now, one way to make a geometric construction is to use tools such as a compass or a straight edge. Now, the next section in section 1.2 has to deal with actually making a construction of a congruent segment. Since I'm unable to do that on an iPad with a compass, we are going to do that in class together. So this next part of section 1.2, we're going to skip over and do in class. Next, we're going to talk about postulate 122. This is called the segment addition postulate. Now keep in mind, postulate 122 is not what I want you to memorize. I want you to know that the segment addition postulate states that if B is between A and C, then the distance of AB plus the distance of BC is equal to the distance of AC. Here's what it means. If you have a segment, and that segment is AC, so point A and point C make a segment. If you have point B somewhere between there, this says that if you take segment AB, or the distance of AB, and you add it to the distance of BC, then the distance AB plus BC would equal the distance from A to C. It's a segment addition postulate. You take one segment, you add it to another segment, and that gives you the entire segment. The distance from A to B plus the distance from B to C equals the distance from A to C. This entire thing is called the segment addition postulate. Segment addition postulate. So let's look at the first part of example 2. Point B is between point A and point C. The distance from A to C is 14, and the distance from B to C is 11 4/10. Find the distance between A and B. Now, when you're looking at this, I can guarantee you in geometry, draw a picture. If you ever can draw a picture to help you out, then do it. So we know that B is between A and C. That means we have point A, we have point C, and B, we'll just put here. B is somewhere between it. We know that the length from A to C is 14, and we know BC is 11.4. We want to find the distance from A to B. Now, looking at this, it's fairly easy. We know from the segment addition postulate, now I'm going to do way too much work here, but I want to make sure you understand that the segment addition postulate states that AB plus BC is equal to AC. So if we know AC is 14 and BC is 11 4/10, AB is what we need to find, then you can write the simple equation, x plus 11 4/10 equals 14. Obviously, most of you, I'm hoping all of you, can look at this and say, well, I would just subtract them because I need to find what the distance from A to B is. So 11.4 subtracted from 14 will give you 2 6/10. So let's do our next example. The second example says that S is between R and T. Find RT, which means we want to find the length of RT. So as you can see here, 4x is the entire length. Each of the lengths that make up that 4x would be 2x plus 7 and 28. So on your own, write an equation to solve for x. What would you write? I'm hoping you would write something like 2x plus 7 plus the 28 has to equal 4x. Notice that we are using, in both examples, the segment addition postulate. RS plus ST equals RT. So we can translate that and put that into an equation. And now you can simplify the equation, which you should be able to do this in your head. So 2x plus 35 equals 4x. Subtract the 2x. And so if you divide by 2, you get the value of x is equal 17.5. But wait a minute. Are you done? This is where you have to attend to precision. The question does not ask to find the value of x. The question asks, what is the value of RT? How would you find it? You plug it in for x. 4 times 17.5 gives you an answer of 70. So the length of RT is equal to 70. Our next two vocab words are midpoint and bisect. A midpoint is a point that bisects a segment into two congruent segments. Bisect just means to divide something into two equal pieces. So as an example, if M is the midpoint of segment AB, now, before we go on, notice what we did here. We're talking about a segment. M is the midpoint of a segment. If you didn't have that here, then you're talking about distance. So if M is the midpoint of this segment, AB, then AM is equal to MB. And once again, a drawing always helps. So if we have AB and M is the midpoint, then we know that AM is equal to MB. So we know those two segments are congruent. Now remember, the segments are congruent. The distances between the points are equal. That's why here we have equal. So if AB, the entire length, is 6, then we know that each of the smaller lengths, which are AM and MB, are each 3. We are now on example 3. Now example 3 is on page 15 in your book. So if you would like to write it down, you may. However, you can just write down page 15 instead, and then write all your work. You still need to write the work down. So in this example, it says that the map shows the route for a race. You are 365 meters from drink station R and 2 kilometers from drink station S. The first aid station is located at the midpoint of the 2 drink stations. How far are you from the first aid station? So the first thing you have to do is analyze what you have. You know that XS is the entire length, which is 2 kilometers. XR we know is 365 meters. RS we do not know. Notice that XR plus RS, which we don't know, is equal to XS. Now once again, we're going to use the segment addition postulate. All we have to do is subtract 2 kilometers minus 365 meters. Well, we first have to convert 2 kilometers into meters, which if you did that, 2 kilometers is equal to 2,000 meters. So we know this is 2,000 meters. So then we know that 2,000 minus 365 gives us 1,635 meters, which is the length of RS. So this right here is 1,635. We know that y is the midpoint of segment RS. So if RS is 1,635, well then RY, right here, and YS are each going to be half of that. So half of 1,635 gives us RY, which is 817.5 meters. So we know 365 meters, plus we now know RY, which is 817 meters and half meters. We have to add those together to give us XY. And what is the length of XY? If we added 365 plus 817.5, you would get 1,182.5 meters. So you are 1,182.5 meters from the first aid station. Notice that you use the midpoint formula, or the midpoint, the definition of a midpoint, and the segment addition postulate to solve this problem. Our next vocab word is a segment bisector. Before you even write this down or look at it, I'm just going to draw something for you. I'm going to draw a segment. We're going to call it AB. M is the midpoint. I then am going to draw a line. Now, the line is a segment bisector. Well, what do you think that does? If the line is a segment bisector, what does the line do to the segment? It divides it into two equal pieces. That is what is called a segment bisector. So a segment bisector is any ray, segment, or line. So this red line can be a segment or a ray that intersects a segment at its midpoint. Notice it intersected the segment right here at the midpoint, point M. It divides the segment into two equal pieces. So the length of AM and the length of MB would be equal. So our last example, example 4, I want you to find x. We know that AM is 5x and 3x plus 4 is MB, and we know that these two pieces are equal because I told you that the line is the bisector. Because it's the bisector, we know they're equal. AM equals MB, so we substitute in. The length of AM is 5x. The length of MB is 3x plus 4. And you can solve that on your own. That would give us 2x equals 4 and x equals 2. Now, if I asked to find x equals 2. If I then asked you to find what is the length of AM, MB, and AB, you would take that 2 and plug it in. AM is 5x, so 5 times 2 is 10. We know MB has to be the same thing, and if you didn't, you could just plug it in and take 3 times 2 is 6, plus 4 is also 10. We know the length of the whole thing was double that, so it would be 20. So our answers would be 10, a length of 10, and a length of 20. And as a review, here is your list of vocab and your list of postulates.